We've talked a bunch about linear equations. We've done proportional relationships, and that's where it runs through the origin. Non-proportional relationships don't run through the origin, but they're still a straight line. Later on, we're going to talk about functions. The great thing about linear relationships, with one exception, is they're always a function. And we'll talk about that one. So we've learned one that was y equals kx, right? We're going to add to that where we get y equals mx plus b. And this is what we're going to be all about this week. M is the slope. We know that very much the same as k. And if you follow along, I'd appreciate it. Thanks. And b is the y-intercept. The coordinates for b are always 0, comma b. Because in the case of the y-intercept, it's where it crosses the x-axis. So if we have a line that crosses, right there is b. It's the y-intercept. It is the point where the line crosses the y-axis. And at that point, x is always 0. So the y-intercept will all be 0, comma, whatever the number happens to be for b. Okay, so how do you tell if a line is proportional or non-proportional? It goes to the origin, kills a Wookiee. Then it's proportional. If it doesn't, it's non-proportional. Now, let's kind of talk about equations versus discrete numbers. So if you fill a tank of water with a hose, when you fill the tank of water with the hose, it starts at 0 and it rises, right? It is a continuous stuff. The hose is pouring in water. If you stop the hose at half a minute, does it still put water in there?
No.
Well, at half a minute, did it still put water up to half a minute?
Yes. Oh, well, yes.
Let's talk about apples. So if I bought some apples, I can buy one apple, right? Can I buy an apple and a half?
No.
That would be nasty. So apples would be an example of a discrete number. Now here's where we get in trouble. If I say pounds of apples, can you buy a half pound of apples?
Yes.
Now, generally when we speak that, we assume that you can find enough apples to add up to make a half pound. And you're not slicing apples up to make sure they make that. If you do that in the grocery store, they will kick you out. And you're like, I'm trying to get a half pound of watermelon. Sir, you cannot do that. I only want to pay for a half pound.
Well,
So,
have you done it?
no. If you buy cars, you can only buy a whole car. Okay? If you're getting puppies, you can't get half a puppy. That's not okay.
Just so much.
Okay?
I want this half.
So, the last thing we're going to talk about, and it probably will be next week, is a system of equations. A system of equations is something like you go to the movies, you and your friend have $20. The cost of tickets for the movies is $8, and popcorn costs $3. How much popcorn can you buy?
One bucket.
But you just did, in your head, you just did a system of equations. Because I can write that in a way that has two variables. One for you and one for them. Okay? So a system of equations is a system, or is multiple equations that use the same variables. If I have y equals mx plus b, and I have two of them, I can have multiple equations, but using the same variables. Therefore, somewhere there's a meeting point. We know what an ordered pair is x and y, right? Now, when we get to systems of equations, we're going to see. Here comes my favorite math joke. You ready? This is the saddest love story ever. Parallel lines have so much in common, it's a shame they'll never meet.
Oh, it's
That was
so
sad.
That is sad.
Isn't that sad? Parallel equations have no solution. If you have a set of parallel lines, they'll never meet. One solution, you have an intersection. Here's the trick. In this case, m is not the same. In the other two cases, the slope is always the same. If the slope is different in your equations, it will have one solution. If your slope is the same, it could have infinite or no solutions. Does that make sense a little bit? We'll talk about vertical and horizontal lines. They are different. A line that's completely vertical, that goes straight up and down, only has an x value, doesn't it? Because it never touches the y. A line that goes left to right only has a y value because it never reaches the x. Okay? Alright, so let's go to the next one where we got some stuff in there.
I like stuff.
I like stuff too. So what's the equation we're really concerned with? Y equals mx plus b, and I'm going to write at the top of my sheet because that way it reminds me what I'm doing, and that makes me happy.
Yay.
So we've got an equation. It says complete the table and graph the solutions for the equation y equals 2x plus 1. Now, what do we know about our stuff? What's the only equation we have right now?
K equals X.
Y equals mx plus b, right? Well, if I do it and write it right under, I found m and I found b, didn't I? By the way, on b and m, be careful you don't drop the negatives. Go spit that out. Or is that paper? You're nasty. I know. It's nasty. If you circle these, remember, don't drop the negatives. It's important. It'll tell what's the way the slope is going, right? So, what is m here?
2.
2. And what's b?
1.
So we know that the slope is 2, and that's also written as 2 over 1, right? Rise over run. You like that? And we know that b is 1, so I can put a mark at 0, 1. Remember, in the case of b, the coordinate is always 0, whatever it happens to be. So the y-intercept is 0, 1. Yes? Now I've got a rise of how much?
2.
What kind of slope have I got? A positive slope or negative slope?
Positive.
Which means it's going to rise up to the right. Yes? So I go up how many?
2.
2. 1, 2. And I go right how many? 1. And there's my point. I get out my lovely handy dandy straight edge. Handy dandy straight edge. And I draw my line. How far does my line go?
2.
It goes on and on and on and on. It has arrows on it. Do not draw a line connecting the points and call it a day. Because this equation actually goes up and down for a long ways. If you need a ruler, go get it. Do not draw wiggly lines. I'll hurt your feelings and mark it wrong. Well, I did a couple of people. So there's my line, right? Now, the problem required, not just do we do the line, but it also wants us to fill in the table. Now, I could do the table off my graph. I'm going to do it a little different. We're going to apply the equation. Our equation is y equals 2x plus 1, right? Well, down here it says x is negative 1. What I do is I go up to my equation and say y equals 2. What's x in this first case? 2 times negative 1 plus 1. What's 2 times negative 1?
Negative 2.
What's negative 2 plus 1?
Negative 3.
Oh no, but all this math
Yeah.
is doing
One.
negative 2.
Negative 2 plus 1.
1.
Negative 1. Good so far?
Yep. Sure.
Now, 0. If y equals 2 times 0 plus 1, what's 2 times 0?
0.
Plus 1? Let's put it over here. Y equals, it's 1 now, 2 times 1 plus 1. What's 2 times 1?
2.
2.
What's plus 1? 3. What's wrong? Okay, let's go to the next one. It is. Why is that? Why is it rising 2 every time? What does the 2 equate to?
The 2, the m.
It's the slope.
Yeah.
It rises by the slope each time. So y equals 2 times 2 plus 1. What's 2 times 2?
4.
Plus 1? And it rows 2 every time, right? So here's what I want you to do at your tables. I want you to do number 2 together. It says the tank starts with 2 liters of ooze in it. And ooze seeps out through a tube at a rate of 1 liter per hour. Write the equation, complete the table, and graph it. Think about it. At your table, work through it. Starts with 2 liters of ooze, and ooze seeps out at the rate at 1 liter per hour. Ooze. It's got ooze in it.
Is that right?
Work with your table. Think about what you got. Remember, the y-intercept is the starting point. Where does the tank start?
Origin.
And slope is always a rate. Work with them.
So, 2 is the starting point. And now it's time.
D is always the starting point.
So
And the
it's gonna
slope
be
is
exactly
the
like
rate.
1.
Rises to negative and you seeps out through it to
I'm getting a hold of you. It would be like this. It would start out at 2. No, it's not, is it? Damn. So you put it
Let's
out.
work with your table. Start with the equation first.
So it's sipping out.
Start with the equation first.
Negative.
Or you can start with the tank. If you have, remember, where did the tank start?
since it goes up.
How much ooze was in the tank at the beginning?
Mr. Willer. Hey, we have another.
Yes.
Because it was brand new.
How much ooze was in the tank at the beginning?
2 liters. And they're just using out 1 every hour.
Mr. Rhodes, since it's losing it, would it go to the
Is it,
opposite
is it, what's the slope if you're losing ooze?
Negative.
It's a negative slope, right?
side?
Up the left. You guys good? You got some problems with yours.
From the origin right here.
We go up
They're saying what they're doing at the rate. It's negative. We're doing positive. It's negative.
It goes like that.
So you go up to. So B is negative 1.
Starts at 2. Oh, that's at 2 hours.
Negative 2.
Got 2 liters of ooze. Fun to put your toes in if you don't want your toes back.
Let me see.
A lot of you are going to it, but think about what you're doing.
The negative.
You start with 2 liters, right?
It would be raising the negative. Right there, it's
And
raising.
you're losing a liter per hour.
It's negative. Positive, negative.
So then.
All right. Let's look at this one. All right. What is the starting point for any equation? What do we call that?
Origin.
We call it the y-intercept, or b, right? In this equation, what do we start with?
2.
The 2 liters of ooze, right? That's our b. That's our y-intercept. And what are the coordinates for a y-intercept? 0, comma, whatever b is, in this case, 2. So there's our y-intercept. We get to add that point real fast, right? If you go down to the table, if x is 0, then the y-intercept is whatever b is, right? So I can do all that. I can, just with that one statement, I can do all 3 of those.
Negative and 0.
What do you mean? No, we're not there yet. I know where you're at. Okay, and it seeps out at a rate of 1 liter per hour, right? What is 1 per hour? If you see per, think slope. Is it a positive? Are we gaining ooze? Or are we losing ooze?
So it's negative.
So we have -1, and that's our m, right? Well, now let's write our equation. So y equals, what's m?
-1.
-1x, and b is a +2. Now, is our slope positive or negative?
Negative.
That means it's going to rise towards the left side, right? So when I go down, now -1, if I want to put that, now I got a fraction, 1/1, right?
Yes.
The rise is 1 and the run is 1, and I want to make sure when I end it's going in a negative slope. So once I do that, then I can make my line with my straight edge, making it the world's happiest line.
That's not a good line.
There's a woggle in the middle of it.
You failed.
It's not even on the dot.
You're right. Don't hate me. Okay. So let's go down and do this part. Now I could do this with a table. If I'd put those better on the line. I really am off the line there. What happened? Okay. Okay, if I'd used this line, I could have gone down here and said -1. When y is -1, what is x? It's that point right there, right? Or, sorry, when x is -1, what is y? What is it?
3.
3. When x is 1, what is y?
1.
1. When x is 2, what is y?
0.
By the way, in this case, if I went out to x is 3, what would be the status of the tank?
-1.
Can you have -1 gallons in a tank?
No, you will not.
It would stop it, and we'll get, that's called a ray or a line segment, and that's really beyond what we're doing here. But that's that. All right, I have now filled out all 3. The hardest part, I think, in this lesson is identifying things. Remember, slope is always a rate. And in a rate, you're looking for something that changes, and they like to use the term per. Miles per hour, miles per gallon, feet per second, right? Anchovies per pizza. Did I gross somebody out?
What did you say?
Pepperoni per pizza. So we could write an equation for that. And B, our y-intercept, is always the starting condition. How do we start? In a proportional relationship, we start at 0. If you're in a car, you cannot jump into a car. I guess you could. But the car at some point still had to be standing still. You could try and cheat it by saying the car was driving 60 miles per hour, but the car at some point was driving nothing.
Wow.
After they get done.
It doesn't matter. At some point, it was proportional, went through 0, right? In that case, our y-intercept is 0. Now, let's take Lexi. Lexi, you get to be used again. Lexi decides to take up a babysitting business. Good job, Lexi. She's going to charge $10 per hour plus $15. The $15 is what she has to pay her parents to drive her to the place, drop her off, and what it cost her for snacks. So if Lexi shows up at the house, her rates are $15 up front and $10 per hour after. So if she worked for 2 hours, how much does she get?
35.
25. Money.
Well, think about it. In Lexi's case, she got y equals $10 per hour, right? Plus 15. If she worked 2 hours, that's $20 plus 15.
That's 35, but she has to subtract $15.
No. That's between her and her parents. It's not between her and the job.
She still makes it.
When the customer gets there, she's still paying that. Right? Now let's say they call Lexi up and say, Lexi, I need you to babysit tonight. And she's like, good. How many hours? Oh, we expect you there for 3. Okay, my rate's $15 up front, $10 per hour. She gets there and said, we've changed our mind. How much do they owe her?
15.
$15. Because that's her rate. Even if she worked 0 hours, they still owe her $15.
Just for calling her out there.
Just for having her drive out there. She still bought snacks that she will probably eat anyway, but she still had them. Does that make sense? That is a good babysitting deal, by the way, ladies, guys. charge them an upfront fee just to get there and back. That way, even if you only babysit a half an hour and they want to pay you like that, you'll at least get paid for your gas. Right? That's a very common thing, by the way. You're going to see it in things like when you guys go and you go for your first job. Some of you are going to do retail. Stop it. Some of you do retail where you get paid a percent of what you sell. It sounds good, except you usually lose money. A lot of those places will pay you like $200 a month plus 10% of all your sales. That way, even if you show up and you sell nothing, you still get $200.
Even if it was like $5 every half hour, that would basically be the same thing.
Yeah, I would not make it every half hour. If it's $5, I would say $10 per hour. If you prorate it, and you can do that in X. If they only made her work a half hour, she could go 10 times 0.5 plus 15. So they'd have to give her $20 if she went. But she'd be good with that because she's got $20. The kids were obnoxious anyway. She wanted to get out of there. She's like, Mom, Dad, come get me. This is awful. The next time she meets them, she says, my rates are $30 plus $10 per hour. Why so high?
Don't know.
Took me hours to come down off that last one. Okay? Any questions on non-proportional relationships? Good.
Bye.